The talk is by Dr. Tulasiramu Ponnada, Principal Software Engineer, Collins Aerospace, Melbourne, Florida, USA. The title of the talk is Beyond Safety, the Security Imperative in Safety Critical Systems. Dr. Tulasiramu Ponnada is a distinguished principal software engineer with a PhD in computer science and engineering. He is specialized in machine learning and safety critical systems. Dr. Ponnada's diverse background includes significant contributions to the aerospace industry, where he leveraged his expertise in safety critical systems to enhance the reliability and safety of complex systems. Transitioning seamlessly from aerospace to healthcare, Dr. Ponnada has applied his deep technical knowledge to advance best-in-class healthcare solutions. He has filed 2 patents related to clinicians' decision support systems, underscoring his commitment to improving patient outcomes through innovative technology. He has actively participated in IEEE and ACM, earning recognition as an IEEE senior member and a fellow of Engineering Research Council. Dr. Ponnada has also played a pivotal role as a liaison for regulatory standards, including FAA DO 178C and FDA IEC 62304, ensuring that these guidelines are effectively implemented in complex software systems. Dr. Venkat, you may share your screen and begin your talk.
Good evening and good morning if someone is on the overseas. And my name is Venkata, Tulasiramu Ponnada. I'm working as Principal Software Engineer for Collins Aerospace, Melbourne, Florida, based out. And thank you for the committee and thank you for Dr. Misbah to make me part of this conference. I would like to present something about, interesting, safety versus security aspects. Okay, so here is the thing. So beyond the safety, the security imperatives in safety critical systems. So here in this today's, maybe we have 30 minutes, and in the presentation, we will little talk about safety critical systems and the security aspects in the safety critical systems. And, there are many safety critical systems, but some of them, where I have hands-on, like aerospace and healthcare industries, I would like to touch base. And what are the key challenges and what are the objectives with respect to the security implementation? I would like to know. Okay. So far, you might have been gone through, algorithm level, details. There are many presentations, keynote speakers, and, invited talks. But this presentation gives you the overall, the process aspects with respect to the regulatory industries, which are mandatory for safety critical systems. Okay. So we will talk about little more about that, as well, what are the regulatory industries for different, different, domains. Okay. So what is, when a system can be called as a safety critical system, if, which, for example, the system failure, if it results in loss of life or significant harm in environmental damage, if it causes any one of them, it will be called as, safety critical system. The best example will be like flight software, for example, landing gear system or flap actuation systems. If you see it, if something goes wrong, there is a huge, risk of, loss of life of the, passengers. The same case with the medical device software, medical device softwares as well. If the decisions are, the operational surgery, operation theater procedures, if something goes wrong with, the software, it can lead to, loss of life. So this is what, safety critical system. These are the 2 examples, especially, aerospace and, medical device industries. Okay. So, okay, what is safety versus, security with respect to the software implementation? If you see, the safety is more, whatever system we are developing, okay, it could be aerospace, it could be, healthcare, or it could be something like automotive domain. So all these things, we have to ensure that, safety means we have to ensure that, the software should be capable of handling, like normal and, like robustness behaviors. That's what, like fault conditions. When it comes to the security, like whatever system you develop, like though it is, like good enough for safety aspects and it is in compliance, like, but security aspects, it protects the overall system from, like intentional malicious attacks or unauthorized access. So, like why both are important for safety critical systems, like in the security breaches, for example, though you develop a well-defined, like safety critical system, if there is a breach and with respect to the security, so it can lead to the safety failures. So what it means is, like safety aspects also, will compromise based on, like the security attacks. Okay. So what are the, like different challenges or unique challenges in the aerospace industry? Let's see, like with respect to security aspects and all. So first thing is like high reliability requirements, like systems, like must operate continuously without failure. And the tolerances are, like very, very minimal to compromise. Also, like many of the audience may be knowing that redundant systems will be there. What it means is line replacement units, whatever we software or whatever, like it's integrated with the hardware. And also there is a redundant system which functions as it is as, like a original system. So in case of failure, like it pitch in and it will solve the problems. So that kind of, like high reliability requirements, there is no compromising in the reliability requirements. So what are the prone areas? If you see the attacking surfaces, if you see it at high level, so increased connectivity for the safety critical systems is exposing to new vulnerabilities. Like in the fast-paced, like technology changes, earlier legacy systems does not have any connectivity in the aerospace or, like aerospace systems and the healthcare systems also. Earlier days, it was more, like a standalone systems. Later, it is, like it is supporting the IoT devices and, like also cloud-based systems. Okay. So those are the surface areas from the black box view. If you see it, like can challenge, like can lead to security compromise. So those are kind of things. And what is the other things are, like aerospace systems, if you see it, it's more legacy systems. Legacy systems means these product life cycles are, like are long and also, like outdated software and hardware, like may result in, like as compromising the security aspects. I would like to talk about little more about, like one of the example where, like uh, where, like we see the security aspects compromisation. So Boeing 787, many of us, like maybe knowing about the Boeing 787. It is, like a Dreamliner kind of thing. So, like around 1 lakh people work for that program. And, like, so the communication vulnerability based on the Wi-Fi access and based on the Wi-Fi and aircraft control systems, like, or, like under control of the remote person, and it compromised, like that compromised the overall security aspects. But luckily, like it was resolved in, like it was resolved very quickly. Though, like it was one of the first issue I can say that in Boeing 787 it happened. Okay, so if you see the what challenges we may have, like healthcare, many of us may directly or indirectly connected with this more healthcare related topics because I mean, like nowadays, like all the mobile devices having, like mobile devices as having, like access to the healthcare related products, like it could be like apps for a decision supporting system, something like that. So basically, again, like we have the PACS is, like a major change in the healthcare industry. That's nothing but, like archiving and, like picture archiving and communication system. What it does is, like it's more about the scanners. Scanner systems, like it archives, it will capture the, like images and, like archives it, and it will also communicates with, like end users. Here, end users, probably a clinician, or I mean, to say that it's a doctor or, like the patients. right? Here, the important aspect of it is patient data. So, there is a separate regulatory industry for, patient data security aspect, that is HIPAA. Okay. And, but however, the patient data compromisation, can lead, it may be a big word, but still I can say that can lead to a death of a patient. So if somebody able to control the vitals of a patient using in a remote system, then, it will harm the patient, especially celebrity kind of patients. There is a chance that it may happen, but yeah, that kind of a cyber threat, we can say that. So couple of examples, if you see, the Medtronic pacemaker vulnerabilities were found in 2019, and it was, it was controlled, the pacemaker was controlled by, the hackers. So some WannaCry attack might be, it was known for 2017 onwards. It was also identified in 2019. It impacted many industries, but one of the industries, UK's National Health Services. So it impacted around, 150 countries, and, major impact was happened at, UK's National Health Services. Okay. So let's see, what regulatory frameworks we have to ensure that security aspects are implemented. So, especially for the safety critical systems, the design from the requirement phase to, verification and validation, it should be as per a particular regulatory body. So there are two bodies, I can quote. One is FAA, Federal Avionics Administration, and Federal Drug Authority. There are the two things. One is for the aerospace, the other one is for the healthcare. Okay. So DO 178C is the one, for the software aspects of software, it covers the software aspects. So it has the list of objectives, to cover what to do. It is kind of a Bible. We can say that DO 178C is a guidelines document, like aerospace industry, it will be, used as it is by adhering all the objectives. So, and DO 326 is a document, you can say that, another guidelines document, which covers security aspects for it, security aspects for aerospace industry. These are the two things. Okay, what is, what it means is, hey, we have one document, okay, which we need to follow. And, it tells us how to gather the requirements, how to design, how to implement, how to do verification and validation, where to see, independency of, independency of implementations, independency of testing, all these things. But, it's kind of a regulatory authority where, a frequency of audits will happen. For example, in the aerospace, if you see, there are 4 types of audits, like SOI1, SOI1, SOI2, SOI3, SOI4. So these audits happen in a regular interval to ensure that, our software lifecycle is implemented as per the DO 178 and also DO 326. Okay. In the similar fashion for the medical device software development, FDA is the one guidelines, it's a regulatory authority, and IEC 60304 is, dictates, the software aspects, the implementations, and it's kind of, like a guidelines. But both the industries, we need to go through the audits, which are driven by the government and the regulatory authorities, and also the certification is mandatory for both the industries in the current context. Okay, so let's little talk about, I don't want to more dig into the DO 178. So, but I would like to little talk about DO 326. Okay, so probably this helps, this helps, security implementations. So DO 326, is, okay, here there are few terms like line replaceable unit, the people will call in aerospace industry. It's nothing but, for outsiders, I can say that a box with, which includes the hardware and software that performs the actual, actual functionality of one of the aerospace aspect. For example, if you want to provide a landing gear system, it is a combination of, hardware and software, which is delivered as a box and uh, aerospace, and which is integrated in the flight. Okay, so one piece of hardware plus software is called as a line replaceable unit here. So this DO 326 covers the certain documents, again a subset of documents that talks about airworthiness of security methods and considerations, information security guidance for continuing airworthiness, aeronautical information system security framework guidance, and process standard for security certification and declaration of ANS ground systems. Okay. Okay. What is the primary focus of it? It's a basically, airworthiness security process and a security risk assessment process and security development process. So these three things are the main focus. The security process tells that, how to implement the security, related security, what we call it as security subtasks to implement in the aerospace industry. And risk assessment is the one, where actual debugging will happen to implement the security. And security development process, tells us that, how to implement or how to embed the security aspects in the software life cycle. Okay. There are three types. There are four levels of assurance level. It's based on, severity of, severity of the security violation. Okay. Those are called as level 0, level 1, level 2, level 3. Okay. So level 3 is the highest. It's a catastrophic or hazardous. If something goes wrong with, if something goes wrong with this level of security aspects, a compromisation will, it leads to a death of, human life. The major is the one, it will may, severe injuries it may lead to. That aspects of things are, configuration files. Probably, if it, compromised at some extent, so it leads to that. Minor things are, it may give the discomfort, but, zero means, level 0 means there is no severity with that, even it is compromised, it won't happen anything. Like, for example, vending machine in the flight, it will not harm the actual functionality of the system. But flight control systems, if it is, it is in the race, then, it damages. That kind of things comes under the level 3. And, level 0 is more about, entertainment systems or supporting systems like vending machine or all these things, kind of more luxury kind. Okay. So the next one, more talks about the security assessment and development. The first thing is as a system, I'm maybe talking about it, define the, overall system functionality we are going to define. And the first question we will ask that, do we have any connectivity to the external devices? If it is no, there is no issues. And if it is yes, we will create a data flow diagrams for that. And then that is, part of, system architecture design. And then, what kind of connectivity we are providing, what are the, surface level issues we may see in the future. Those are part of identification of the potential threat conditions. So based on that, whatever threats identified, possible threats identified, there will be a, there will be a group of people who will do the functional hazard assessment. So if it is compromised, these aspects, possible aspects, so how it impacts the overall system functionality. So here, if it is a major hazardous, or we talked about level 0, 1, 2, 3, right? If that kind of threat conditions are there, if it is not there, just if it is not those categories, then it is good. We can document and we can stop our analysis. But if it is a major or hazardous, identify the threat scenarios and develop, like mitigations, security mitigations. We need to do it. Okay. And then once we have the security mitigations in place, it should embed with, like all our requirements development process. That's nothing but system requirements, software requirements, and hardware requirement. It has to flow through. Okay. Also, like all these mitigations will be having the bidirectional trace with, like requirements development process. What it means is, like what is the mitigation we have and which system requirement is handling this mitigation. And also you can see the complete flow from the system requirements to software requirements, and some requirements probably part of hardware requirements, some probably part of mechanical requirements. And then if it is a software aspects we are covering today, so then how it is transformed into design and architecture, and how it has been tested in the part of verification and validation also. It will give a complete flow from the risk mitigation to its implementation will be there. And also there will be security assessments will happen periodically. So to assess the mitigations against safety and also security requirements. So, and though I'm not covering the other part of it, that's nothing but safety aspects. Okay. Safety in the similar way, we will be having the safety mitigations and also will be having it. So this is kind of, like intersection portion where we see it, like without compromising the security. Are we accomplishing the safety or not? Like that can be, it's a kind of priority item with respect to this life cycle. So once we, with all these mitigations, if we meet the safety objectives, then verification plans and validation plans will take all these mitigations for verification. Thanks. Okay. And verification results will drive, like will ensure or it will provide an evidence to the authorities saying that, hey, these are the security, like threats identified, and these are the mitigations, and these mitigations are implemented this way and also tested by this means. So it's all, like evidence-based industry. So the complete flow will go through in this way. So though, like it is, I know that it is very high level, but I would like to bring it up because, like it gives, like overall flow of, like how it has been implemented in aerospace. Just I would like to cover that. So this is the software lifecycle model. It's which covers, like defines the security compliance plan. It's more about, like how we are going to implement the security compliance in given system, and security environment, the definition of the security environment, vulnerability, threat identification, likelihood of issues, all these things, and how identified issues or threats, like impact the functionality of the overall system, and the security risk assessment. All these things are, like you can visualize. It's a simply, like a V model, but each and every phase of, like software life cycle, what are the different activities we will be doing it, part of, like security. These are this diagram will present it. Okay. And and how this security risk management happens. Now, certification related activities. Usually we will be having the PSAC plan of, like software aspects of certification. That's more about the safety. But here, security aspects, it will be called PSAC AC, and we will call it as then, like security scope, assessment, like are the risks are acceptable. If it is not acceptable, like security development and all these things, whatever we covered in the life cycle of earlier slide, these things will be, like handled. So the thing is like, like saying is different, and providing evidence for each and every aspect or each and every activity is the challenge here. So the in short, I can say that, like the risk mitigations are completely should be embedded in the architecture. That's where it's demands. Um, Probably key security imperatives and threat modeling and risk assessment is the one. And the secure software development lifecycle will help in this. And continuous monitoring and patching is the another thing. In the aerospace, like real-time monitoring of onboarding systems, and healthcare, if you see regular updates to the medical devices and the hospital networks. authentication and access control, zero trust architecture for both sectors, and ensuring only authorized personnels and systems can access the critical components. Okay. Um, I will I will try to make it simple. Maybe let's take one of the aerospace incident analysis of like a known aerospace security breach. For example, like UAV hacks or UAV hacks are like connectivity related hacks. If you see it, so the basically it will lead to the system failure. Just I would like to say how it. I mean, like there may be a kind of a question always like how it impacts the safety failure. Okay. The safety systems are driven by the configuration files. So, like if you take any of the flight software, it will be having a different variants, and each variant will be having its own, like a configuration files, which has the, like predefined information about that particular variant. So what it means, like if you see the flight planning or fuel quantity measurement, or like if you see landing gears or flap actuation systems, it defines the parameters used in critical algorithms. So those parameters are defined in, like configuration files. Okay. Those configuration files, because of, like security breaches, like if it is, like hijack or it's in the control of the, like third party, then what will happen, like it changes the flow of, like the software. That way, indirectly, like it leads to like unsafe landing, or there is a chance that like crashes in the air. So that is the relationship between the security, how the security breach can lead to a system safety, and like unwanted crashes. Okay. What lessons we can take it is like gaps in the system security architecture, and how stringent, like security system software, SSDLC, could have mitigated the risk is the one thing, right? So if it is failed at the architecture level, then what happens? Like there is a high chance that, uh, uh, a high chance that, say, unsafe crashes. And healthcare probably, like it's many, I mean, like people can relate with this. Ransomware attacks on the medical devices is a common thing. We are seeing many years. And downtime in what impacts it does, like it's a downtime in hospitals, and threats to the patient care it does. So if it's something, if we compromise the patient data, there is a chance that, like patient death as well. As I said, like it's more about the vitals, or, like patient healthcare plan, like diagnosis. And if it is hampered, like definitely there is a chance of, like loss of life. So integrating security into safety critical system, and the culture of, like security awareness from the requirement space, that is critical, and the collaboration across the teams, like these are the huge systems, 1 lakh plus people may work across the globe. So the collaboration matters a lot, like implementing the security aspects and identifying and listening to, like, what breaches can happen in the aerospace industry, right? From the different teams, and collaboration is needed. And use of standards and best practices is another thing. Like, as I said, like there we have regulatory industries as well as the organization driven standards also, like can help in integrating these things. Emerging technologies and machine learning and safety critical systems, quantum computing and 5G and beyond these things. Also, like emergent technologies and future threats it can lead to. Best practices and recommendations, like gap analysis is one of the thing for aerospace, and for healthcare, regular vulnerability assessments needs to happen, and strong authentication methods needs to taken care. Like here, I'm not talking about any encryption, decryption, or authentication methods and everything. It's more about, like what needs to taken care at the what is needed by the regulatory industries. Okay. And what we can take away, what we can take out of this presentation, if you see the importance of integrating security and safety I hope it is established. And also a point that security gaps can compromise the safety and leading to catastrophic outcomes. Here, catastrophic outcomes means, like crashes in the air, and that is for the aerospace, and loss of life in the patient, if it is an healthcare domain, loss of life in the patient, uh, uh, loss of life of a patient, we can say that. Aerospace and healthcare sectors needs to stay vigilant, like in evolving the threat landscapes, invest in security measures, promote collaboration across the domains, because, like use, like it's used in systems also, like different domains of people will work for a one product delivery here. So keep security imperatives at the forefront, so that if it is identified at the system level requirement itself, so that, like it ensures that complete life cycle is, intact with the overall implementation. That's all I have. Thank you.
Any questions? Any questions from the audience? Okay. Thank you, sir, for this compelling session. You have provided us with a very comprehensive view of the landscape.